right, this is part 2 of Introduction to Limits. I've copied down the graphs that you guys have on your worksheets. We're going to get to these guys in just a second. Before we get to that, I want to consider this function right here. F of x is equal to x squared minus 1 over x minus 1. We just finished discussing rational functions, and so from that point of view, we can talk a lot about this. We could say, hey, does this guy have any vertical asymptotes? Are there any holes? What is the horizontal asymptotes or oblique asymptotes? What's going on right here? We could discuss all of those things just from that perspective. And so if we look at this right here, how we discussed holes and things like that, we said, could we factor the numerator? And we can, in fact, factor it. This can factor into x plus 1 times x minus 1 over x minus 1. So going into this, we would say there's going to be a vertical asymptote at x equals to 1. However, if you factor it and you find that it's got a common cancellation, which it does, then x equals to 1 is no longer a vertical asymptote. It is just a hole. And so what we're allowed to do is work with the simplified version of this function, y, f of x equals to this, or simply y equals to this, with the understanding that x is not allowed to equal 1 because it's undefined right there. So let's just graph this guy because we know how to graph this. We've seen this before. This is just a line, y equals mx plus b. What's the slope right here? Well, it's 1 over 1. And what's the y-intercept? It's 0, 1. So let's just graph this. Here's my y-intercept. I'm going to rise 1, run 1, get my slope. And so this would be my line right here. All right, that's fine. That would be the line. However, this was not what we started with. We did not start with the linear function. We started with the rational function, which has domain issues. And the domain issue is that x equals to 1. So you go to where x is equal to 1, and you go up here, and you have to put like a little open circle. That is old news. We have already done that. Let's talk about limits. What happens when x approaches 1? That's the question. This is another way to put that. What is the limit as x approaches 1 of f of x? That's what we're asking. So in order to answer this, we must look at it from the left and the right to see what's happening. So what is the limit as x approaches 1 from the left? And also we must ask, what is the limit as x approaches 1 from the right? So let's look at our picture. As x approaches 1 from the right, as we're coming in here, we're writing it, it looks like it's headed for this open circle right here. Right there. That's what it looks like it's headed for, okay? As x approaches 1 from the left, it looks like it's also headed for this open circle. The question is, what is that y value? Well, that y value is whatever this would be if it was defined, and so we can just plug 1 into this function. Y equals to 1 plus 1, or y equals to 2. This is the value 2. The limit as x approaches 1 from the right is 2. The limit as x approaches 1 from the left is 2. These agree, so the limit as x approaches 1 of f of x is 2. What you see here is called the substitution principle. If I were to just substitute in right here, if I were to substitute 1 into here, I would get 1 squared is 1 minus 1 is 0 over 1 minus 1 is 0. I get a 0 over 0. So when you get to calculus, you're going to learn a new term which is called an indeterminate form. This is an indeterminate form, 0 over 0. When that happens, the limit exists, you just have more work to do. So the more work that we had to do in this case, and this is one of the things you'll learn to do, is factor and make a cancellation. And once you make that cancellation, when you substitute in 1, you don't get 0 over 0 anymore. You get 2. Here is another case. It's on the purple sheet, so let's just look at that. Let's try the substitution thing in. It's number 7 on the purple sheet. What is the limit as x approaches 2 of x squared minus 2x over x squared minus 4. If we were to use direct substitution in this case, we'd say 2 times 2 is 4, minus 2 times 2 is 4, over 2 times 2 is 4, minus 4. We get 0 over 0. We get an indeterminate form, 0 over 0. It is undetermined. We don't know what the limit is. More work to do. So here's the more work that we do. See if we can factor it. So this is equal to the limit as x approaches to 2. You could factor out an x in the numerator and get x minus 2. You could factor the denominator, this is difference of squares, into x plus 2 times x minus 2. And here we see there's a hole at x equals to 2. If you get that cancellation, you can work with the simplified version. The limit as x goes to 2 of x over x plus 2. I can use direct substitution. 2 goes in for the x, and I get 2 over 4. It turns out that the limit as x goes to 2 of this function, although it's undefined at 2, has a limit of 1/2. So that is something you're going to talk a lot about when you get to calculus. Right now, look at these crazy charts that I gave you. We're going to talk about these. And so I didn't give you any problems on the worksheet, so I'm about to put them right here. So I'm going to give us 12 problems for us to do. One of them has to do with this function over here, f of x, and the other has to do with this other function, g of x. And so these are the type of problems you'll definitely see something like this on the final exam. So right here, let's just split this down the middle. These are the ones I want us to answer for f of x. So let's do that. Let us look at, oh no, I did maybe not split it down the middle because I did all kinds of crazy things. Okay, let me just figure out what I want. Let's do this one. Number 1. What is the limit as x approaches 1 from the right of f of x? What is the limit as x approaches 1 from the left of f of x? What is the limit as x approaches 2 from the left of f of x? What is the limit as x approaches 2 from the right of f of x? All right, let's see. What is the limit as x approaches -1 of f of x? What is f of -1? What is f of 2? What is the limit as x approaches 3 from the left of f of x? What is the limit as x approaches 3 from the right of f of x? What is f of 3? All right, let's go through here. The limit as x approaches 1 from the right of f of x. This is f of x, this is x is 1, this is the right side of 1. So we're writing in the curve and we get close, it looks like it's landing right there, and that y value is 0, okay? The limit as x approaches 1 from the left of f of x. Okay, we're on the left side of 1, we're writing in the curve, and it looks like it's landing at that same point, so the y value is also 0. The limit from the left side of 1 and the right side of 1 agree, so we can make this conclusion. The limit as x approaches 1 of f of x exists, and it's 0. All right, how about the limit as x approaches 2 from the left? Okay, 2. As we approach 2 from the left side of 2, we're close, we're getting up to 2, okay? This is equal to 2. The limit as x approaches 2 from the right, we're coming in here, it equals to 2. Okay, so we can say, yeah, the limit as x approaches 2 of f of x equals to 2. The limit exists and it's 2. Now let's just go back up here and take a look at this. What is f of 1 defined to be? This is not a limit. This is not anything new. This is what you've been doing for years now in your math life. Just evaluating a function at a value of x. So what is the y value when x is 1? When x is 1, the y value here, see it's closed circle, it's 0. All right? It's defined, f of 1 is defined to be 0. What is f of 2 defined to be? F of 2, when I go to 2, I see an open circle. It is undefined. Did that affect the limit? Not a bit. The limit existed even when the function was undefined. So f of 2 is undefined, but we know that that doesn't affect the limiting value. All right, over here. The limit as x approaches -1. This time I didn't give you from the right or from the left. What you have to know is be savvy enough to know that I got to check it from the left and the right. So right here at -1. From the left, it's honing in on this value. From the right, it's honing in on this value. It is agreeing that the y value is going to be 2. The limit as x approaches -1 is 2. What is f of -1? What is it defined to be? Well, when I look, the closed circle is up here. It's defined to be 3. Okay? Oh, and I already talked about f2 is undefined. We already talked about that, undefined. right here. The limit as x approaches 3 from the left, 3. From the left side of 3, I'm coming up here, and it's approaching the value 4. That's 4. The limit as x approaches 3 from the right, 3 from the right is down here, it's 1. The limit as x approaches 3 of f of x does not exist because those don't agree. Is the function defined at 3? A totally separate question. Is it defined at 3? Well, sure it is, because I see a closed circle up here, and it's defined to be 4. Understand that where something's defined has nothing to do with what its limiting value is necessarily. Okay, now let's look at totally separate picture, g of x. I just gave you two different things just so we could have two different pictures to look at. So don't worry, these are not related. So we're done with f of x, so we won't look at him anymore. Let's just concentrate on g of x. Let me ask you some questions about him. Let's see, what about the limit as, let me get a different, the limit as x approaches, as x approaches, the limit as x approaches 2 of g of x. Right? And what is also g of 2? Let's answer that. What is g of negative 3? What is the limit as x approaches negative 3 from the left of g of x? What is the limit as x approaches negative 3 from the right of g of x? What is the limit as x approaches negative 3 of g of x? Okay. What is, let's see. What else do I want to ask? What is the limit as x approaches negative 5 from the right of g of x? All right. What is the limit as x approaches negative 5 of g of x? Okay, we'll just do a few more of these. I think you're totally probably getting it by now. The limit as x approaches 2 of g of x. Okay, if they do not give me from the right, from the left, that means I have to, on my own, look at it from the left and the right. So, at 2, what is it as x approaches 2 from the left? It is getting close to this value, 4. What about from the right? It's getting close to this same value, 4. I can say the limit as x approaches 2 from the left and the right is 4. So the limit as x approaches 2 of g of x is 4. Totally separate question. What is g of 2 defined to be? G of 2 is defined to be 1. This, by the way, is called a removable continuity. That you'll learn about that in calculus. But anyway, let's see. G of negative 3. This is not a limit. Do you see the word limit? No. What is g defined to be at x is negative 3? There's a solid circle. It's on the x-axis. This is equal to 0. Let's answer these questions. What is the limit as x goes to negative 3 from the left? So as I'm creeping up here from the left, it looks like it's approaching this value and a 0. What is the limit as x approaches negative 3 from the right? So if I'm on the right side, I'm creeping up on it this way, and it's up here at y is 1. What is the limit as x goes to negative 3? This side said 0, this side said 1, but those do not agree, so this means does not exist. That's what you put there. Okay, last question about negative 5, and then we'll be done. The limit as x approaches negative 5 from the right. Here's negative 5. Here is the right. As we get closer and closer to negative 5 on the x-axis, it looks like it's honing in on this y value, which is negative 3. But what is the limit as x goes to negative 5? Well, that means we have to look at it from the left and from the right. Look at the left side of this. I see no picture. I see no graph. I cannot talk about the limit at x equals 5 because I cannot even discuss what's happening from the left. This only has a right-sided limit, so this does not exist. We have no graph, no picture to discuss that other side. All right, that is an introduction to limits.